Hello, I'm Steven with DMA Engineering. I'm here today on a luxury residential project here in Cherry Hills Village. We started working on this house back in 2010. We did a controls retrofit on the house. It had 4 heat pumps. These are the new heat pumps. We installed a Niagara system to control the heat pumps, and we put an air side zoning on the 5 fan coils that were here at that time. Since that time, the house has had about 5 different homeowners. The latest homeowner bought it in 2020, or about 2019, and started a small remodel, turned into a significant remodel. And in that time, the project changed a lot. The installing contractor installed new heat pumps during that time. And these heat pumps here, they went from old Con-R units to these newer type units that can do the higher heat with them. So there's a little bit of fanciness there with those heat pumps. Anyways, DMA did some design work on the project. In about 2022, the house was turned over. The mechanical contractor had some personnel changes, and the system didn't get started up as well as it should have. It didn't get fully commissioned. We weren't part of the commissioning for this side of it at that point in time. So there was some issues with it. Needless to say, here it is, 2026. Installing contractor was trying to maintain the system, was struggling to keep it maintained well, and yeah, lo and behold, we ended up having one of the heat pumps had some issues. They troubleshot it down. I think they misdiagnosed a couple of things there, but we had a compressor go down in one of the units. So they started investigating that. They brought out the the manufacturer, flew out, took a look at it, and they said, hey, the flow isn't where we want it to be, which is kind of interesting, because if you go look at the data for what they say is flow, I'm going to bring you in here. Hopefully you can get in there and you can see the flow that they recommend goes off the chart. So it's kind of interesting. In this table here, doesn't even give the flow that they're telling us that they need to meet now. So that's put us in a little bit of a pickle. We had to do a little bit of a redesign to figure out how to get the flow where the manufacturer stating that they want to see it. So what we ended up having to do is the ground heat exchanger. It's kind of not a really good heat exchanger. 400 foot tubes, 400 foot tubes with 1-inch pipe, and then it's 1.5-inch headers that run about 400 feet to the loops. So a lot of head loss in this ground heat exchanger, especially with these new units with the flow they want to see on them. A lot more flow, a lot more head loss. So we're really, we couldn't meet it with just the pumps that were installed. Those source pumps there weren't going to do it. So we had to come up with a design. So we ended up decoupling the ground heat exchanger from the pumps. The installing contractor bowed out, said, hey, we're out of here. We don't want any more to do with this. So DMA Engineering stepped in. It designed and implemented that big pump that you see up there, Grundfos CR3 pump that we're using to pump into the ground heat exchanger. And then since we're hydraulically decoupled, those small pumps, the source pumps, will pump in to just that side, and then that will pump into the ground heat exchanger, give us the flow that we need. We're going to use 0 to 10 volt, or we're going to use delta T on the pump with that VFD there, getting a 0 to 10 volt based upon the delta T, which is coupled to the BAS system, the Niagara BAS system. We'll be able to control that pump. And then on the source side, we were just a little bit low on what they wanted to see with this new flow requirement. So we came back in and added in these Taco pumps here that can take a 0 to 10 volt. A little bit more flow than the Grundfos Alphas that would fit that. So this pump in series with that pump will give us what we need to get to the flow to make sure the heat pump is meeting the new manufacturer's requirements and get this system back up and running. So again, yeah, the installing contractor bailed out of this. When you work with DMA Engineering, as long as you're cool, the homeowner on this project's super cool. So we're able to come back in here, get it working. That's what we do. DMA makes sure that we stand behind what we do. We're going to get it up and running, get this system running for the homeowner to be happy for multiple years. Thanks.